In this video, you will learn how to factor using the difference of perfect squares formula. This involves factoring a binomial or a polynomial with two terms. Let me know if you have any questions in the comments below, and don't forget to subscribe so you don't miss out on future videos. Let's jump right in. How to factor difference of perfect squares. So first of all, it's super important to even know what these words mean. Difference, a reminder, means subtraction, and in this case, what are we subtracting? Perfect squares. But what does perfect square mean? A perfect square, very simply put, is a product or a multiplication of something times itself two times. So for example, this x squared minus 9 polynomial, why is this a difference of perfect squared? Because if we look at the first term, x times itself is x squared. So the square root of x squared is x. Or you could look at that as our definition up here, the product of something multiplied itself twice. So x times x is x squared. The 9 is also perfect squared because 3 times itself gives me 9. And then very, very, very importantly, it's a subtraction between those perfect squares. So I've seen many, many times x squared plus 9, if this was a separate example, notice it's the sum of perfect squares. No, you wouldn't even be able to use this formula. As a matter of fact, x squared plus 9 is not even factorable. So be super careful of taking note of it should be subtraction, or else it wouldn't even be called different of perfect squares. Okay, so here we have a formula. So don't get too tripped up in the formula, but typically the first term, right, we could have called it any variable, but in this case, people call it a. So the first term is just a squared, and the second term, we call it b squared. And so we're subtracting them. So in this particular case, the a term would be x, and the b term and the b would be 3 in that particular case. Okay, so a lot of people, what they like to do is on the side, they like to write what is a and what is b, because after you do that, you can just substitute into that template. So the template is you add a and b together and you subtract a and b together and you write them as a product. Okay, so a reminder, what is a? It's the square root of the first term, right? What's a reminder? The square root of x squared is x. So that would be our a. And we had 9 as a second term, so b is the square root of 9, which is 3, right? That was our b. So in this particular case, if we wanted to factor x squared minus 9, we would just use the formula, and just by substitution, it would look like x plus 3 times x minus 3. Now, does it matter which way you do it? Actually, no. If people wrote x minus 3 times x plus 3, because of the commutative property of multiplication, it would be the exact same answer. So either one of those would be correct. So let's go ahead and do a little harder example, right? So we have 81 minus 4x squared, excuse me. So first of all, you need to recognize that this is a difference because you're having a subtraction here, but are they perfect squares? So this represents the a squared, and this represents the b squared, and we're subtracting them. So notice over here, I set us up with a equals b equals. It's very important that you do that so that your brain doesn't get lost. Okay, so what is the a term? It's going to be the square root of 81, which is 9. So a equals 9, and b is going to be the square root of 4x squared of the second term. So what times itself is 4x squared? 2x. Okay, and if you're not sure, again, you can do a check, right? Perfect square means you can split it up as a product of something times itself. 2x times 2x is 4x squared. So you know that works. Okay, so once you have your a and b, now we can just, right? So this is a and this is b. So we can just plug it into this formula. So it would look like 9 plus 2x times 9 minus 2x. And again, it doesn't matter if you did the subtraction one first or the addition one second. Doesn't matter the order. So we're done. Now, a good thing that teachers technically like to see, they might even add that in the directions, always do a check to make sure you've done it correctly. So if you did the distributive property, 9 times 9 is 81. 9 times negative 2x is minus 18x. 2x times positive 9 gives me plus 18x. And finally, 2x times negative 2x is a minus 4x squared. So whenever you do the check of difference of perfect squares, you should always end up with the middle terms canceling out, right? Those guys equal 0, and we are left with 81 minus 4x squared, which is the original problem. So what if you just have something like this, right? So again, this would be considered a squared, and this would be considered b squared. But honestly, you don't really have to know that. Don't get tripped up because now we just have all these letters. We have A, B, W, T. I can see how students might feel confused about that. So really the important thing you should really know is that A is going to be the square root of the first term, and B is going to be the square root of the second term, right? And so we have subtraction of those perfect squares. So again, A is the square root of the first term, 36w squared, and B is going to be the square root of the second term, or 100t squared. And again, perfect square means something times itself equals that perfect square. So 6w times 6w gives me 36w squared. So that's A. And 10t times 10t itself gives me 100t squared. So that's correct. Right? So that's our A and that's our B. So finally we can plug it in. It's just going to be the addition and the subtraction. And obviously the parentheses are super important. Okay, also make sure that the A is written first, right? So if we look at our formula, notice the A is written first and the B is written second. So I did say that you can switch around the parentheses. So you can write the second guy first and then the first expression. Now we can write that second. So these two are fine, right? So we can do the commutative, because of the commutative property, we can switch those around. The only thing that you can't switch around are the B and the A, right? So if instead you did this, 10t plus 6w, that's fine because addition is also commutative, but now you run into trouble if you were to write this, right? Notice you did b minus a. So subtraction, the commutative property does not hold for subtraction. In other words, that's just a fancy way of saying subtraction, you cannot switch around those two terms. So what I'm trying to say is just to make sure when you figure out your A and B, you always write A first. I hope this video helped you learn how to factor using the difference of perfect squares formula. If you're interested in other factoring methods, I'll leave the link to those videos in the description below. If you like this video, make sure to subscribe to my channel right now. That way you don't miss out on my future videos like this one.